Hello everyone, I'm Cheng Xinru. Today I will demonstrate a series of tasks using Databricks. Throughout this process, I will showcase the results directly in the Databricks interface and highlight the platform's key features. Now, let's begin with some simple basic setup examples. I created a table called department and insert some records. We can see the table here. We can see its depth name and its location and so on. It is worth mentioning that Databricks can guarantee permissions through secure statements, and this demonstrates Databricks' enterprise-grade governance and access control. Next, let's zoom to Databricks notebooks. Wait a minute. Okay, we can use multiple languages in Databricks such as Python, SQL, R, and so on. Here I will show you how to import data using Python. I imported a CSV file about New York State baby names statistics. First, I set some parameters and covered it into a data frame. And then I saved it as a table. Here is a table, and I use the visualization editor to make a chart. It is very convenient in Databricks for visualization. We can just click here and click the visualization to make a chart. In this visualization, we choose the type as word cloud and count the baby's first name. We can see that visualization is very straightforward in Databricks. Now, I show you another example. I query New York taxi data. This is a table about the data, and we can also use the editor. Here, we choose the fare amount as X and the trip distance as Y, and group by pickup zip. From this chart, we can see that with a fare amount of $52, the average trip distance for pickups from zip code 1001 is 16.97 miles. Next, moving on to secure queries. I performed some analysis still using the taxi data. First, I counted data trips by pickup zip code and found the top 10 business areas. The business pickup area is zip code 1001, then 1003. Next, I calculated the average trip duration and the average fare across all taxi rides. On average, each taxi trip lasts about 15 minutes and costs around $12. Then, I extracted the hour from each taxi pickup timestamp and grouped the data to count the number of rides per hour. This helps identify peak travel times. From these results, we can see that the evening rush hour peaks at 6 p.m. with 1,455 taxi pickups. Finally, I analyzed the daily fare trends by converting pickup timestamps into weekday numbers, mapping them to weekday names, and selecting fare amount and trip distance. These results were visualized to review patterns across different days. We can see the longer the trip, the higher the fare tends to be. And we can see some details. For example, this trip is in Wednesday and the fare amount is 95. The trip distance is 12.49. In the data engineering section, I built an ETL pipeline. We can choose here. The DAG views in the right sidebar shows 3 tables: songs raw, songs prepared, and top artists by year. The update summary appears at the top of the asset browser, and the detailed table information is shown in the bottom. You can click on any table to explore its contents. So next, I explored the datasets created by the pipeline. I ran ad hoc queries in the Databricks Secure Editor to analyze the processed song data. First, I queried the top artists by number of songs released each year since 1990. We can see that Beastie Boys had the most released in 1994, 5 songs in total, and the Maximo Park released 4 songs in 2009. Then I ran another query to find songs with a 4/4 time signature and a danceable tempo between 100 and 140 BPM. We can see the results that Eminem's song Funk had a tempo of 124.389. Let's back to workspace. Wait a minute. Finally, although our course did not cover machine learning, I'd like to briefly highlight one of Databricks' most powerful features, scalable ML workflows. Using a wine quality prediction model, I first applied Spark to process and merge red and white wine datasets. Then prepared the training and test sets. With MLflow, the experiments were automatically tracked, including parameters, metrics, and model versions. And then I further applied Hyperopt for hyperparameter tuning of a gradient boosting model and registered the best performing model in unit catalog. The log output of Hyperopt illustrates how Databricks seamlessly integrates data engineering with machine learning workflows. Finally, MLflow's queries allow us to extract and review the best model run records. To sum up, I demonstrate several key strengths of Databricks: its support for multi-language programming, powerful secure and visualization tools, also integrates great access control via secure. The data engineering section showed how Databricks supports full ETL pipelines, while the machine learning workflow integrates Spark, MLflow, and Hyperopt for automated experiment tracking and hyperparameter tuning. Overall, Databricks offers an end-to-end unified platform that seamlessly connects data analytics with AI workflows. That's all. Thank you for listening.